Yes, so as Flo says, this session I'm pretty excited about, and we planned this a long time ago to try and bring everything together with some fabulous speakers who are going to take us through the day, looking initially at the science and the priorities for our science going forward, and then we're going to hear from users and practitioners, their needs, and then we're going to hear about communication, telling stories, and how we engage the public with these issues. So yeah, I really don't need to say too much more. The way we'll run it is there'll be 4 talks in this first session, and then we will have a panel discussion for half an hour. So I'm going to ask the speakers, you can use your whole 20 minutes. We won't have questions after each talk, and we'll save it for the panel discussion. And Flo and I have one tricky question to ask each panel, and so we will ask the speakers to respond to this tricky question, and then we'll open it up to the group. Okay, my voice is not sounding too good this morning. I apologise for that, but it's a real thrill to open this symposium, Melting Ice, Rising Seas, and to welcome Valerie up to the stage to kick us off. Thank you, Valerie.
So, good morning. Thank you for this invitation, and thank you for the opportunity to be the first speaker after the conference dinner yesterday at this early hour. I hope you're completely awake. So this presentation builds on insights from the 6th assessment cycle of the IPCC with 3 special reports, the 3 working group reports, a synthesis. It's the opportunity to thank each of you who has contributed to the advance of lines of evidence that were integrated to provide this snapshot of the state of knowledge in evolving fields typically related to the understanding and projections of the implications of climate change in and around Antarctica. I summarize the 3 main findings from the synthesis report with 3 words: the seriousness of the current situation, the urgency to change pace and scale of climate action, and the possibility to act, the agency. The solutions that exist, and if deployed, could halve global greenhouse gas emissions until 2030 and implement adaptation at scale. I also want to highlight, thinking of the science-society policy interface, several resources that have been developed to reach out to different audiences. Classroom material for teachers from the Ocean Cryosphere report, resources for the general public, plain language summaries translated in various languages of the physical science basis, summaries for urban decision makers or actuaries to inform risk assessment and a community of practice, and resources for scientists interested to reach out to different audiences with principles for effective communication and case studies from different IPCC authors in different world regions. I'm now moving to how Antarctic-related issues were addressed across those reports. In the 1.5 report, it was mostly about what we know and don't know in terms of implications for sea level rise from the Antarctic ice sheet response to sustained warming at different levels. There was much more depth in the Ocean Cryosphere report, as reflected by the references to Antarctica. For the land report, despite implications of sea level rise for land erosion, salinization, and implications for large deltas, it was not much mentioned, so it was not on the highlight on approaches to food security or water security. Of course, there was a strong emphasis in the Ocean, Cryosphere, and Sea Level chapter of the Working Group 1 report. You can see the number of occurrences of the world, as well as in the Working Group 2 report on impact, risks, and adaptation responses, in particular related to sea level, but also related to polar regions and their unique biodiversity and ecosystems. No mention in the Working Group 3 report on mitigation, and I'll come back to that. So how were these reports received in the field of climate negotiations within the United Nations Framework on Climate Change, or UN? Following the SROC report at COP25, there was the setup of a dialogue on the ocean and climate change. The COP26 decision, following the Working Group 1 report, had a whole statement about science and urgency, and the COP27 decision, for the first time, recognizes the impact of climate change on the cryosphere and the need to further understand these impacts, including tipping points. And it also led to informal discussions, followed by more formal discussions, still blocked, within the UN Security Council, related to issues of climate change and security. That meeting I attended remotely was organized by Vietnam, one of the countries with a large delta, particularly exposed to consequences of sea level rise. So if we look at where we are in terms of human influence on global climate, you can see greenhouse gas emissions that continue to increase, of course with unequal, historical and ongoing contributions. And I have provided an update to the IPCC synthesis report based on data up to 2019, published in Foster et al. Last June. So you can see the pandemic and rebound effect. No peak CO2 has been reached yet, no sign of decline, which is one key condition to have hope to be able to stabilize warming when net zero CO2 emissions are reached. Thinking of Antarctica, you can also look at greenhouse gas emissions in the perspective of Antarctic governance, the Antarctic Treaty, the Protocol of Environmental Protection, with a commitment from parties who basically support our science, to the comprehensive protection of the Antarctic environment and ecosystems, and only in 2023, a declaration of parties to the treaty encouraging Antarctic operators to continue to reduce their carbon footprints. And that will be a growing attention on our own science and our own practices, as well as on tourism activities around Antarctica with growing footprints, basically destroying what we want to preserve. Thinking of human-induced warming, the IPCC report shows without any ambiguity that human activities are responsible for heat accumulation in the climate system and surface warming. It is mainly driven by the increase in global greenhouse gas emissions, but it is also fed by the decrease in emissions of pollution particles and the loss of their cooling effect. In the last decade, these two factors go in the same direction. A few years later, this again update to the IPCC findings, again growing global emissions, growing concentrations of greenhouse gases in the atmosphere, larger effective radiative forcing dominated by human activities, increase in the Earth's energy imbalance with a question mark whether it's accelerating in fact, human-caused warming reaching 1.15 degrees Celsius with the attributed part to human influence almost equal to that. No possibility so far to update from the current state of emissions and warming what will be committed sea level rise, and I'll come back to that. We also see widespread impacts and related losses and damages driven by changes in multiple physical climate conditions. In the Working Group 1 report, we look at 33 of these climate impact drivers, increasingly attributed to human influence. And you can see cryosphere effects either locally, glacier retreat, or globally through global sea level rise, as well as mention of compound risk, for instance, from extreme rainfall and extreme sea level, that have particular importance for coastal cities. I place an emphasis on this because economic development is disproportionately concentrated in coastal cities and settlements worldwide. So the trend of exposure is increasing, the hazards are increasing, and then there are very different ways to deal with sea level risks related to different aspects of vulnerability. And the Working Group 2 report is very clear that current governance, institutional arrangements are unable to address the escalating risks in low-lying coastal areas and worldwide. Let's now dive into what we know about the state of climate cryosphere in the Antarctic region. We understand that the uptake of heat in the Southern Ocean is directly related to greenhouse gas emissions. It absorbs about 45% of what the global ocean absorbs. We understand that stratospheric ozone and global greenhouse gas emissions have contrasted influences and play a role on trends in the southern annular mode. There's contrasted Antarctic temperature and sea ice trends. Ice shelves are thinning, and it's due to basal melt and sometimes to hydrofracturing from strong surface melt events. There's increased mass loss from the Antarctic ice sheet, dominated by what's happening with outlet glaciers from West Antarctica and the role of basal melt. Parts of the East Antarctic ice sheet have lost mass in the last 2 decades, and there are many changes in the Southern Ocean near the cryosphere. But in terms of understanding, that understanding, so not just detection, but also attribution, it's constrained by the large natural variability and the limited observations, or what can be inferred from paleoclimate records, discrepancies between models and model limitations, improper representation of all processes, and therefore many questions about their adequacy for questions we want to address with them. And as a result, there's low confidence in attributing the causes of Antarctic sea ice changes as reflected in 2021. I cite one recent paper suggesting that ocean warming may play a role in sustaining wind-driven Antarctic sea ice loss recently. And in the IPCC, there's limited evidence and medium agreement of human influence on the Antarctic ice sheet mass balance, driven by changes in ice discharge. Looking at global mean sea level, it's obvious that it's accelerating. It's one of the few characteristics of the climate system where there's acceleration. So the rate has increased. The rate is unprecedented since at least the last 3,000 years, but we know from the past that ice sheet instabilities could cause higher rates than currently, sometimes from ice sheets that have now disappeared. It's also obvious that heating of the climate system, mainly driven by our emissions of greenhouse gases, is driving global mean sea level rise. The cryosphere role is now dominant, and one core reason for the observed sea level acceleration is the net amount of mass loss from the Greenland and Antarctic ice sheet, multiplied by 4 between the 1990s and the early 2020s. There's only one paper cited in the IPCC report, in fact with no confidence, about estimates of committed unavoidable future sea level rise, which suggests it could be around 0.7 to 1.1 meter by 2300. It also provides an assessment of the initial Paris Agreement pledges, increasing these numbers by typically 10 centimeters, showing the inadequacy between pledges and what would be needed to slow the rate of sea level rise. This needs to be revisited. Your science can help advance that. Of course, local relative sea level rise increases the profile of coastal risks. And these hazard changes and impacts are already observed in areas with subsidence. So they are like emergent signals. It is a problem because many insurance companies only take issues seriously when they have observations of observed impacts and losses and damages. And because it's not yet observed in many regions, it's not yet high in the agenda of what matters economically. So coastal impacts, they include ecosystems and their loss, with implications for carbon storage, but also human livelihoods, infrastructure, food and water security, in particular with salinization, but also things that have human value, such as cultural heritage, and issues associated with habitability in some regions. We don't yet have the ability to assess the compound and cascading risks, in particular for those most vulnerable. So it matters in terms of being able to have the right tools. One study on worst-case extreme sea level in the future suggests that the main source of uncertainty is not related to cyclone projections, but it's related to the amount of sea level rise after 2050. And this uncertainty is driven by what we don't understand about the Antarctic ice sheet. So looking at the future by 2040, exposure is going to rise to coastal flooding. And you can see the number of people in gray exposed today. In orange, the number of people due to population trends in light, and due to the rise of sea level, which is about independent of scenarios, in dark orange. Look at the audience in this room. This community is not well distributed worldwide. And that's a challenge for having people able to translate Antarctic science, sea level implications to local decision makers. Just think of, difference in terms of exposed population. We worked across the IPCC reports to be able to translate in simple way how an increase in mean sea level affects the return time for extreme sea level events, as illustrated here for events which occurred in the past, recent past, once per century, and could in the future occur once every 10 years, once every year. And this is illustrated by the color of the dots here by 2040. So this is robust science that needs to be incorporated in decision-making, risk management, adaptation planning, and that would be the least cost choice. It's not yet the case. After 2050, the leading uncertainty on the rate, the magnitude of sea level rise, comes from ice sheet projections. So let's first look at future warming. If we would put all emissions to zero now, a view of the mind, there would be no further warming. So the inertia in terms of surface warming doesn't come from the climate system. It comes from existing infrastructure that will emit fossil fuel over its lifetime and future decisions that affect the profile of fossil fuel emissions. The yellow-orange curve, SSP2 4.5, is the one closest to current policies. Contrasted emission trends across regions, stagnation during a few decades, slow diminution. In that case, it's the failure of the Paris Agreement. A level of warming of 1.5 is expected to be exceeded next decade, and a level of 2 degrees would be exceeded by mid-century, with higher and in fact more uncertain warming by the second half of the century. For that, we used global climate projections constrained by observations, constrained by the estimate of climate sensitivity from multiple lines of evidence, including paleoclimate insights. And this allowed to reduce the uncertainty on future climate projections for a given scenario. And the same emulators are used to classify the many socioeconomic pathways developed in other communities. This does not speak to most people. What speaks to most people is, why does it matter? Why does it matter for what I care for? And you care for the Antarctic climate, ice sheet, cryosphere. But what do people care for? And my experience is that many of them care for unique biodiversity and ecosystems. So this is what we had in the Working Group 2 IPCC report in terms of the severity of risks for sea ice ecosystems, marine mammals, seabirds, and fisheries. And there was recent evidence for breeding failure for many emperor penguin colonies associated with recent sea ice loss, which made headlines everywhere. So we also need to find ways to communicate why different levels of warming matter for what we would like to preserve, conserve, transmit for other generations, not just cryosphere, climate physics, the sea level rise, but also other forms of life on Earth. So regarding projections of future changes in the Antarctic region, this is not a figure from the IPCC report, it's an extract of the relevant statements within the chapter that basically highlight low confidence, uncertainty, and deep uncertainty. So medium confidence for projections of the mass balance changes and that it will play a negative role on sea level rise. Low confidence in Antarctic amplification this century. A colleague of mine just published a smart analysis of data suggesting it may be there, but masked by large variability. Low confidence in sea ice projections. Uncertain projections of ice shelf disintegration. Low confidence in what's happening at the ocean ice shelf interface. Uncertain role of meltwater feedbacks. And low to medium confidence in land vertical movements. Altogether, there's deep uncertainty with processes of instabilities, marine ice sheet instability, ice cliff instability, But there's a potential of those processes to strongly increase the Antarctica ice sheet mass loss. How to communicate that? At the beginning, our chapter was focused on, the likely range, medium confidence processes. We received a letter from scientists really concerned that it was a misrepresentation of the tail of risk that can matter for decision-making. As a result, we had two approaches to reflect sea ice projections. An approach consistent with climate sensitivity, global surface temperature projections using emulators, and processes where there's at least medium confidence. And then a high-end storyline accounting for low confidence in ice sheet processes associated with deep uncertainty. I take this figure from the paper of Roderick, who will dive into details later on, and there's a potential to make these approaches far more robust and transparent and evolve with our state of understanding. So in terms of communication to decision makers in the IPCC synthesis report, this is how it is reflected. We highlight some of the hazards and implications. We highlight the exposed population, why it matters. We show that future sea level after 2050 depends on future emissions, so we can act and limit the magnitude and rate of unavoidable sea level, but it also depends on uncertain ice sheet response. And this is illustrated by 2100, 2150, and 2300. It reflects the conclusions of the report for Antarctica that ice discharge will likely outpace increasing snowfall, and the uncertainty on ice sheet instability, therefore expressed through a low likelihood, high impact storyline. In the report, it's available for a 2-degree scenario and the high-end emission scenario. In this display, it was only shown for the highest emission scenarios, which is perceived compared to current emission trends, technological advances, cheap low-carbon electricity or possibilities now. It's perceived not to be plausible. As a result, many people misunderstood that curve, and I tried it recently, and thought that the instability of Antarctica ice sheet in particular would only be triggered with very high emissions. So we need to think carefully how to convey, it's in the report but not in the visual, our understanding that it could also happen for lower emission scenarios with more robust evidence. After 2100, huge uncertainty, low confidence due to the lack of post-2100 projections at the time of the assessment. And maybe to convey the sense that the main uncertainty on more than 1 meter sea level rise is not when it will happen, is when it will happen, but not if it will happen. And that was one of the purpose of that visual, which matters for risk-averse coastal decision makers or long-lasting infrastructure and long-term planning. We also highlight the potential drivers of high-end sea level rise and specific ice shelves in this century. But the state of challenge is not there yet. There's no agreed methodology to converge whether it's already triggered, it's committed, what are the early warning signals, what will be the observational constraints that can be incorporated to shift from a low likelihood possibility to something that has already been triggered. We highlight that responding to sea level rise requires long-term planning, and therefore we show for different geographies the severity of the risk and how much of that could be mediated by very high adaptation efforts. And this is perceived to reflect a security threat for some geographies, some regions. Looking at the time for planning and implementation of coastal risk management and the lifetime of different options, the intent was to illustrate hard limits to ecosystem-based or sediment-based coastal adaptation. It buys a bit of time, but with high rates of sea level rise, it doesn't work anymore. The report highlights the importance of maladaptation, in particular because coastal infrastructure gives a false sense of security, tends to concentrate assets, and when the capacities are overwhelmed, leads to, in fact, higher losses and damages compared to retreat and relocation. So one thing that is missing, and why Antarctica ice sheet aspects are not reflected in the mitigation report, is knowledge associated with the demand for energy, materials, costs, and implications for mitigation potentials on coast, where they have to invest into adaptation or face increased losses and damages. And that loop is not there yet. Trying to convey the information from the report to practitioners requires to provide information relevant at the local scale. So the Sea Level Atlas, hosted by NASA, is an attempt to provide the translation of the regional sea level projections at tide gauge sites. And you can see that it is heavily constrained by the lack of tide gauge information, in particular around many coasts of Africa. No information is available because it cannot rely on at least 1 decade records, reliable records from the tide gauges. So this is really something critical to be able to convey information for areas where it strongly matters, for fast-growing coastal cities, for instance. So this is an example of a milestone at Trieste, where there is a remarkable tide gauge record, illustrating the median and likely range of sea level projections for the timing when half a meter more is reached, including the low confidence projections for 2 scenarios, showing how much this tail of distribution could make the milestone occur earlier. And I think it helps to translate that knowledge and limit to the knowledge at the local scale. But is that going to be used? Will practitioners, will local governments, national governments build on the IPCC assessments? This is something to be looked at. And there's an attempt in the report to communicate clearly the ambiguity in sea level projections. But what will be simplified for use at the national scale remains to be monitored and explored. And you have a role in your countries, in your communities, to give a voice to that knowledge so that it can be embedded in the most operationalizable way. I'm a paleoclimate scientist, so I like the long term. And thinking of sustained warming at different levels and sea level implications makes me think of our legacy. That aspect of irreversibility matters for many people. They really hate the idea that what they do, their lifestyles, has implications for coasts they care for ecosystems they care for over thousands of years. But the state of knowledge remains really limited in terms of levels of warming associated with irreversible loss of sectors of the Antarctica ice sheet. There's hope that new paleoclimate evidence on magnitudes, contribution rates, better use of that information to relate local conditions and global ones associated with thresholds and tipping points. And I really enjoyed Frank's presentation, turning the question the other way around and asking, what are the conditions that would allow to avoid triggering instabilities? And so what's a sort of safe space for some Antarctic sectors? And I think that type of information also matters in terms of mitigation strategies. A core message from climate science is the relationship between future warming and cumulative CO2 emissions. And the margin that remains is expressed in terms of remaining carbon budgets. With the current rate of emissions, the remaining budget to limit warming to 1.5 degrees will be surpassed by the end of this decade. And existing and planned fossil fuel infrastructure will overwhelm that by itself for the 2 degrees budget. So it really matters to convey our knowledge on sea level rates, magnitudes, long-term commitments in a way that can be also translated in that framework. I can translate a kilogram of CO2 to glacier mass loss. I can translate a ton of CO2 to Antarctic sea ice loss. But how to translate that for the Antarctic ice sheet? What matters? Cumulative? Rate? I don't know. I don't know how to explain that. And it matters for some aspects related to decision making. So we'll overshoot a level of global warming of 1.5. What does it imply in terms of accelerating higher committed sea level? We don't have information yet. In the IPCC report, it's reflected as higher risks, immediate and delayed risks, but we need more information, more substance, targeted scenarios with different magnitudes and durations of overshoot. On the policy world, the discussion is also shifting to different types of intervention, solar radiation modification. The IPCC report takes an approach of a widespread range of new risks, the lack of governance, and a source of potential larger tensions between countries. There's emerging literature about uncertainties, limited effectiveness for polar climate, possible unintended effects for the Antarctic ice sheet, and also implications in terms of irreversibility through over how much time would you have to deploy such interventions. And I think it matters in that debate on solar radiation modification. And my last point is about using economic decision-making tools. The Antarctic ice sheet response is absent in the Working Group 3 report because there was almost no literature. There's new literature, for instance, looking at coastal adaptation costs, residual damage. It could increase by around 7% for low-emission scenarios, the social cost of carbon, basically saying it's even more worth to invest in reducing emissions compared to the scale of the costs implied if you don't do that. So this is also a way to translate that knowledge into information that matters. And there are huge aspects associated with equity. In theory, a rational decision would be to invest now into proactive adaptation. But it's not happening. It's not happening where you live. It's not happening in the poorest regions for the poorest communities. So how to take stock of real world, the adaptation gaps, the uninsurability of coastal regions, and what will be their social and economic actual implications for development and growth. So altogether, I tried to highlight why does advanced understanding of the Antarctic ice sheet cryosphere matter. It's exciting science, frontier research. There are geopolitical dimensions, and we operate under the Antarctic Treaty. But there are also core issues associated with what is dangerous climate change for different regions, different people, different time horizons, and irreversibility, and knowledge to inform economic-wise action. I mentioned unique biodiversity, societal implications, and we can translate what is at stake in terms of habitability, security, economy, and maybe even more important, equity. Thank you.
Perfect. Thank you. Yep, that's right.
Oh, look, thank you.